Welcome back for part two of our interview with Sam Hensler from Dynamic Analysis. What are some indicators that there may be structural issues at a home?
Sure. Can be tricky because I have seen really specific cases where there was nothing apparent. No one would have known unless they started measuring the house. I think the most extreme example is a house that had 18 inches of differential settlement. This one was enough that any person could tell just by looking at it that everything was off, and then walking across it one way was more difficult than walking across it the other way. That was a really special case where it was involved in a landslide, but it was built so well, it was built on piers, that it all moved so perfectly that there wasn't a single crack in the drywall, there wasn't a single crack in any of the concrete.
Wow.
Everything was just off, so it's not a perfect, there's no perfect way to tell if there's an issue or not.
Yeah.
But the by far most common symptoms are going to be cracks in your drywall. Drywall is a very rigid element that's not very strong, so if there's any movement it's going to crack very readily. So having a crack in your drywall isn't necessarily an indication that you have structural issues. It may not even be an indication that you have structural movement, but it's going to be a symptom if you do have structural issues or structural movement. It's kind of like if you have a cough, it doesn't mean that you have the flu or cancer, but if you have the flu, you're going to have a cough.
Yeah, gotcha. What about door jams? If we're looking at door jams, since that's kind of a 2x4s can get cockeyed and
so doors are a good indicator, and they'll actually tell you which direction things are moving. If you have a door that doesn't have an issue, and then over time it starts to develop an issue, either binding, meaning it gets sticky to either to close or to open, it's probably rubbing in the jamb. And the door is hung on one side, so if the hinges move further down than the latch side, then there's going to be a gap at the top of the door where the latch is at, and it might be rubbing on the floor on the bottom, and that'll tell you over the width of that door that it has moved, whatever that gap is, the difference in that gap is, and it's further down on the hinge side than it is on the latch side, and vice versa.
Okay.
If it's binding at the top, then that means that it's moved on the latch side, it's settled on the latch side and has dropped that much. So they're kind of really easy, quick litmus tests to see if there's been some differential across a doorway. There's also issues where if the door just won't stay in a certain position because it's not plumb anymore. It might just always want to close or always want to open. That could be an indicator. There's always the factor that it could have been not framed perfectly, or could have been framed so tight to begin with that the minor amounts of adjustments in thermal expansion and contraction, or differential humidity. So if it's near a shower or something like that, and it uses something like MDF that swells when it gets moist, and it was really tightly hung, it might bind when it's hot or when it's humid, and then not when it's dry or when it's cool. So again, not a perfect, not a definite indicator that you have structural issues, but it usually will accompany a structural issue. And same thing with cracks in the concrete. I think one of the things I hear most frequently in defense of cracks in concrete is that concrete cracks, and that's definitely true. When concrete cures from its more liquid form into the solid state, it shrinks chemically. It's an exothermic reaction. It gets rid of heat and energy, and in so doing, it becomes a smaller volume than when it was originally placed. So that's your shrinkage, and you're going to get shrinkage cracks from that. Those are relatively minor though. If you have a large crack, if you have anything that's even, if you can measure it in terms of millimeters, that wasn't because it shrank. That's because it moved after it was placed. So certain types of cracks, worse than others. Horizontal cracks may mean something different than a vertical crack. Vertical cracks don't necessarily mean that it's not an issue, because there are certain things that could cause a vertical crack that are concerning, but most of the time they're not as concerning as like a horizontal or diagonal crack.
Okay. What about displaced cracks? So one edge off another.
Yeah, displaced cracks, especially in either case, is a more serious issue, because that means that they're, assuming we're talking about, say, a basement wall, the job of a basement wall is to keep the soil back. You have soil in your yard, it wants to be in your basement, and you have a foundation wall that keeps it in the yard and out of your basement. It's constantly pushing against that basement wall, and if it's starting to win that fight, it'll start to displace the wall. So if you have vertical cracks that are causing the wall to bow in, you might have a condition where it's separated from the floor and the wall is now tipping in, and that's going to develop a vertical crack that's concerning because the wall is leaning in, and you'd have like a series of 3 cracks in a case like that, one where it's widest in the center when viewed from the basement, but thin on the outside, and then 2 cracks on the outside where it's thinnest on the inside, widest on the outside, because that wall is kind of broken into a handful of pieces and is now leaning into your basement. Same thing with the horizontal crack. Displacing horizontal crack is because that wall's lost that fight with the pressure from the soil, and the soil is now making its way into the basement, and that basement wall is now stretching and bowing inward. And once it's begun to bow, once it's begun to get displaced, and that horizontal crack's developed, it's now less capable of keeping that soil at bay, but that soil's still there. Unless you remove some soil, that same weight is still going to apply. So it's going to take less moisture introduced to that soil to push it even further. And then that creates this feedback loop where the wall gets weaker, the soil's able to push it in more, makes the wall weaker, which means it's easier for the soil to push it in more, and then eventually it kind of grows and accelerates to a point where it needs to be replaced. So it's something you could catch relatively early and fix for relatively cheaply by adding tensile capacity to that wall so it can't be pushed in anymore.
Gotcha. That makes sense. Thank you.
Mm-hmm.
How concerned should a potential buyer be if they, this goes right back to what we were saying. If they see cracking on a basement, vertical, horizontal, I think we kind of just covered a lot of that. But overall concerns for a regular buyer walking through a house.
Yeah. I mean, I think it's hard it can be a relatively complicated issue, so it's hard to just say, don't worry about it if you see a crack. I mean, in general, you should have some amount of concern. If it's, for the majority of cases, small vertical cracks or a series of small vertical cracks just isn't going to be concerning. But in certain cases, you can have cracks that are telling a story about what's going on in the house. So say there's vertical cracks, just a bunch of small vertical cracks. Those cracks aren't really concerning for the integrity of the foundation, but they might be telling a story that this foundation is experiencing a lot of stress. And those cracks might be occurring along, say these 2 walls because this corner of the foundation is just sinking, which means that we have an issue in the subgrade here, and that's developing these vertical cracks. So it's not that the cracks are a concern, but they're telling a story about what's happening in the soil.
A symptom.
Yeah, exactly.
Cool.
So, but if you just have one vertical crack in the middle of the foundation wall on a house that's 40 years old and it's less than a quarter of an inch wide, and it's on the gable side or the side that has a triangle on the wall, that probably is just because that all the weight is on the other 2 walls and those sunk a little bit. There's not much weight on that wall, so it bent and it cracked there. That's going to happen on almost any house in the soils that we tend to have in this area that has that sort of construction.
Okay, that makes sense. So if you saw that happening and you went upstairs, because it's going to be exaggerated the further away from the source, right? Would that be true?
Not necessarily, just because there's a lot of flexibility in the wood. So technically, the further you go up, the more that bending or that stress is going to be attenuated just from the flexibility in the structure itself. So when we take measurements of the foundation, what we actually measure is the main floor that's sitting directly on top of the foundation, because that's the easiest thing to measure that's as close as possible to the foundation.
Yeah.
And that'll give us the most accurate readings. It's not going to be necessarily 100% accurate because you could have some separation between the floor and the foundation. So you could potentially measure less differential elevation than what the foundation is actually experiencing if those 2 things are starting to separate, or in certain cases, which is something we check for, if someone has relayed new floor or put in some sort of floor leveling compound to kind of help alleviate that floor sloping. Those are things we have to check for when we're taking a measurement. So, but generally, as you move further away from the foundation, it gets a little bit diluted through the flexibility in the structure.
Gotcha.
Not in all cases. If it's a really rigid structure, it might exaggerate, just like you're saying. But in most cases for light frame wood construction, it's going to kind of attenuate as you get farther away.
Disperse out. Okay, that makes sense. What are some geographical indicators to be aware of in this area?
So what I always tell people is, if you want a house that's going to be in a geologically interesting area, it's going to have some geologically interesting issues. So there's a reason that the geology of any specific area looks the way that it does. And if it's really complex and interesting and fun to look at, that means there's a lot of complexity happening in the soil around that area, which is, complexity in the soil is not necessarily something that you want in a foundation, in a subgrade for a foundation. You can design through most issues, so as long as you have the right team, say if you're building a house and you want it to be in a geologically interesting issue, you'd want to have the right team to fully assess all of those issues and make sure that the structure that's designed to sit in that place is adequately designed to deal with those issues. But if it's just a standard home on interesting soil, it might have some interesting issues down the road.
Okay, I like it. That's a good way to put it.